Good morning, class. Today we will be learning about sensation and perception, about the eyes and the ears and all the processes that go along with them. First, let's discuss the different parts of the eye. The rods are photoreceptors that detect black, white, and gray. Rods also help you detect movement. They are necessary for peripheral and dim light vision when cones do not respond. Your cones are also photoreceptors, but they detect color and fine detail in daylight or bright light conditions. Got it? The eyes are very complex and full of parts that work together to help you see. Next, you have your cornea, the transparent curved layer in front of your eye that bends incoming light rays. The rays are then transported to your iris, the colored muscle that regulates the size of the pupil opening. They pass through the hole in the iris known as the pupil, which is smaller in bright light and larger in darker areas. Then they are bent by the lens, the structure behind the pupil that changes shape to focus incoming rays into an image on the retina. There's more, guys. Stay with me. Your ganglion cells are the third layer of neurons in the retina, and their axons converge to form the optic nerve. This is the nerve that carries the neural impulses from the eye to the thalamus, a part of your brain. You also have what is known as a blind spot, the region of the retina where the optic nerve leaves the eye. This means that there are no receptor cells, so it becomes an area with no vision. Now, I know what you're all thinking. Don't worry. There are other parts of your eye to make up for it. Overall, your eyes work to develop depth perception, which allows you to judge the distance of objects. Another fun fact, there are things called optical illusions, which are discrepancies between the appearance of a visual stimulus and its physical reality. Ruben, earlier you had a question about glasses, so let me explain. There are two different types of visual conditions that can make it difficult to see. Many people are nearsighted, meaning that they can see nearby objects more clearly than distant objects, me for example. However, people can also be farsighted, where they are able to see faraway objects more clearly than objects that are closer to them. This is a condition also called astigmatism, which is caused by an irregularity of the shape of the cornea or lens. This distorts and blurs the image of the retina, making it difficult to see clearly. Where did we learn this, you ask? There have been many different people who have studied the eye, and many theories have been made regarding its function and structure. The two main theories are the trichromatic theory and the opponent process theory. The trichromatic theory was created by two men named Young and Helmholtz, and it accounts for color vision. These men stated that there are three different types of photoreceptors, which are most sensitive to different wavelengths. I know this can get confusing, but basically they believe that cones are most sensitive to red, green, or blue. This means that every color you see is made from a combination of these colors. The opponent processing theory, on the other hand, is based from a man named Ewald Hering, who believed that certain neurons can either be excited or inhibited depending on the wavelength of light and its complementary wavelengths. Okay everyone, last part, I promise. Basically, there are many processes that your eye goes through to allow you to see. There's a thing called dark adaptation, which is increased visual sensitivity that gradually develops when it gets dark. Your eye is constantly changing to adapt to its surroundings. There's also parallel processing, where your eye simultaneously analyzes different elements of sensory information like color, brightness, and shape. Overall, your eyes work very hard to allow you to see. Alright class, that's the lesson for today. If you have any questions, please come to me after class. I'm sure I can help. Have a great Monday.
Okay. Hi, Miss Chadwick. I was wondering if there was any way you could explain this to me. Like that right there. I'm having trouble because there's so many terms.
I'd be happy to help you. The information is quite easy if you break it down. Come join me for a second. I think I can help.
Really? Thank you so much, Miss Chadwick. I really appreciate it.
How much time do you have?
All the time in the world. What is that?
It's the portal to your mind and body. Let's explore.
Okay, Miss Chadwick, I'm in.
Alright, Ruben, here's our last surprise stop before we go back to school. Welcome to the ear doctor. This is Dr. Thaddeus Morphemus, the finest ear doctor in town.
Hey Ruben, I hear you're learning about sensation and perception in your psychology class and having a fairly difficult time. I hope your visit here will help.
I'm looking forward to it, Doc.
Okay, Ruben, so first I'll explain a few general terms, and then I'll hand it off to Dr. Morphemus. In layman's terms, your actual sense of hearing is called audition. It explains that the loudness of a sound is determined by the height of the sound wave itself. Don't get it confused with audition for the theater.
Miss Chadwick, what is the height of a sound wave and why does it matter?
Well, amplitude is the height of a sound wave, and it looks like this. This matters because it tells us how loud a sound is. The larger the amplitude, the louder the sound. Now this is measured through frequency, which refers to the number of complete wavelengths that pass a point in a given amount of time. It helps to determine the pitch.
This is so much to comprehend. I have so many questions. How are our bodies able to understand what we are hearing?
That's a solid question, kid. And the answer to that lies within a few theories. Here, let me explain. The first theory deals with how we understand pitch. The place theory describes the position on the basilar membrane where sound waves reach their peak. It is important not to forget that this depends on the frequency or pitch of a tone. The second theory we need to understand is called frequency theory. This explains the rate of neural impulses traveling up the auditory nerve matches the frequency of a tone, which again helps us determine pitch. In case you didn't pick it up, pitch is very important.
So, enough about the theories. How do people lose their hearing?
Well, there are two types of deafness as well. Conduction deafness is essentially the loss of hearing that results from a puncture in the eardrum, or if any of the ossicles lose their ability to vibrate. This is often the most common and mild cases can be restored with hearing aids. Nerve deafness, however, occurs when the cochlea, hair cells, or auditory neurons are damaged. The only way this can be resolved is through cochlear implants.
Thank you so much, Dr. Morphemus, but we must be going. Lunch is almost over. I hope you learn a lot from these doctors, Ruben.
Well, I definitely did. Thank you.
That was fun, wasn't it?
Sure was. I learned so much.
There's still so much more to learn.
More?
Yes, more. Let's go over the more broad stuff, and I'll help you break it down. Sound good?
Yes, Miss Chadwick.
Great. Sensation is the process where you detect physical energy from your environment and encode it as neural signals. To put it simply, it's the use of all 5 of your senses.
Touch, sight, smell, hearing, and what else?
Taste. In comparison, perception is the process that organizes the sensory input and gives it meaning. Basically, it takes what you've experienced and helps you understand it.
That makes sense.
Sensory receptors detect something called a stimulus, which is any change in the environment. It helps your body know how to react. This relates to something known as the difference threshold, which is the smallest difference between any 2 stimuli that a person can detect 50% of the time. This varies from person to person.
Got it.
Good. I'm glad this is making sense. It's a lot of information to learn, but it's not that hard to comprehend. So, the absolute threshold is the minimum stimulation needed to detect a particular stimulus 50% of the time.
How's that different than the other one you mentioned?
The difference threshold? Good question. Basically, the absolute threshold is the point where something becomes noticeable to our senses. It's where a stimuli goes from undetectable to detectable to our sense. The difference threshold, however, is the amount of change needed for us to realize that a change has occurred. The change is called the just noticeable difference because you just notice that something has changed.
That's clever. And that makes sense too.
Great! There's also something known as a subliminal stimulation, which is when someone receives messages below their absolute threshold. This means they aren't consciously aware that it was ever there. Isn't that neat?
Very.
There's also sensory adaptation, which allows you to focus your attention on information changes around you without being distracted by irrelevant data like odors or background noises. It helps you determine what's important without being weighed down by the things that can't help you. This relates to perceptual constancy, where you believe an object has not changed even when the immediate sensation of the object changes. Your mind works in mysterious ways.
Wow. There's so much more that goes into thinking than I ever imagined.
It's cool, isn't it? Weber's law is another idea that states the difference thresholds increase in proportion to the size of the stimulus. The bigger the stimulus, the bigger the difference needed to detect a change.
Remember you saying something about schemas? I don't know what they are though.
I almost forgot. Schemas are concepts or frameworks that organize and interpret information. It's basically a general idea or representation that someone has when they think of something. We're almost done, Ruben.
Yay! Can't believe we have learned so much in one day.
Lastly, there are two different forms of processing that you experience. The first is bottom-up processing, where information begins with sensory receptors and works up to the brain's integration of sensory information to form perceptions. This is usually data-driven and starts with how your body experiences different stimuli. There's also top-down processing, which is the opposite. The information is guided by our pre-existing knowledge or expectations, which works to construct perceptions. This is typically concept-driven. Make sense?
Yes, it does. Thank you, Ms. Chatter, for all your help today.
You're so welcome, Ruben. I'm glad you finally understand. Maybe you can help me tutor the other kids during lunch.
I would love to, now that I'm enlightened.